Hello. In our previous presentation, we discussed about the implementation of stack using arrays and its applications. In this presentation, I'll be covering the implementation of stack using singly linked list, and some of the applications we'll be considering so that those applications will be implemented by using singly linked list. So before getting into the implementation of stacks using singly linked list, we'll have a brief introduction about what is a stack and what are the operations that can be performed with respect to stack. Stacks are linear list. All deletions and insertions occurs at one end of the stack known as top of the stack. Data going into the stack first and leaves out last. Stacks are also known as LIFO data structures, that is last in first out data structures. So the basic operations that can be performed on stack are push and pop. The push adds an item onto the top of the stack and pop removes an item from top of the stack and return it to the user. And stack top, it's a structure. It takes two elements, top and peak. It copies the top item of the stack and returns it to the user. The item is not removed, hence the stack is not altered. So coming to the implementation of stack using singly linked list. Since all the actions happens at the top of the stack, a singly linked list is a fine way to implement it. The header of the list points to the top of the stack. So this is the structure of a singly linked list. It consists of some 4 elements, and my stack, it is a pointer which is pointing to the topmost or whatever it is, the front element of the singly linked list. So pushing is inserting an element at the front of the list. Whatever we will add, that element will be pushed at this end, and popping is removing an element from front of the list. And with a linked list presentation, overflow will not happen as it happens with respect to the arrays. So because we'll not be knowing the exact size of the stack, here there is no overflow concept in case of singly linked list. Underflow can happen, so one should handle the same way as for an array implementation. When a node is popped out from a list and a node references an object, the reference does not need to be set to null. So these are the some key points we need to keep in mind while implementing stack using singly linked list. The one major disadvantage of using an array to the implement stack is the wasted space. Most of the time, most of the array is unused. A more elegant and economical implementation of stack uses a linked list, which is a data structure that links together the individual data object as if they were links in a chain of data, as it is illustrated in this particular figure. So this is a singly linked list. Elements are elements are linked together in the form of a chain. So stack structures are usually implemented using arrays or linked list. For both the implementations, the running time is order of n. So we'll be elaborating later this implementation of that is this complexity and all. We'll be explaining the common stack applications in this presentation. So the common stack applications are reversing a data, and for example, the reversing files are strings, and also it is the stacks are very useful for finding palindromes. See, consider one a simple pseudocode to reverse a string or to reverse a palindrome, whatever that is, to find a given string is palindrome or not. So consider the following pseudocode to understand how the stack has been used to implement those applications. First, we'll read the data, and we need to loop the data until not end of file or stack not full. Push, we are pushing the elements onto the stack, and that is read the data. This process continues, and loop while the stack not empty, and we'll pop out the elements from the stack, and then we are printing it. So in the reverse order. So that is the element which is recently pushed onto the stack will be taken out first. We are printing the string in the reverse order, or whatever is end of file, or a palindrome, or you take anything. So some more applications of stack is converting a decimal to binary. So we'll take one simple pseudocode here. We are reading the number and loop the number until it's greater than 0, and we are taking each digit and we are printing that digit, and we are dividing this number by 2. This process we are repeating. With this code is that it will print the binary number the backwards. So it is we are printing in the reverse direction. To remedy this problem, instead of printing the digit right way immediately, we can push it onto the stack, and then after the number is done being converted, we pop the digit out of the stack and print it. So these are the simple applications of stack, and these applications can be implemented more efficiently with the help of single linked list. So we have applied the stack concepts, and we have used the single linked structure to what is that solve these application problems. Similarly, we can consider some more applications, that is evaluating arithmetic expressions and evaluating that is prefix, infix, and postfix. And also in high level languages, infix cannot be used to evaluate this. So we must analyze the expressions to determine the order in which we evaluate it. A common technique is to convert infix notation to the postfix and then evaluate it. Thank you.